So keep in mind as we're doing these, what we are attempting to do is use the limit process to actually find the area under that curve. So what we're trying to do is find this shaded space using a better approximation tool than a Riemann sum, a midpoint sum, or a trapezoidal sum. So as always, when we add up all these little tiny rectangles in here, okay, we know we have to do the formula area equals length times width. And basically, we don't know how wide these are. It's kind of an arbitrary value at this point. So we've learned in the lessons today to find the width, we have to take the values of the endpoints and subtract them. So I have a 1 and a 0. So this is going to be 1 minus 0, and then I'm going to divide that by n. So my width is 1 over n this time. Then I always look at my starting value here. I know that it's 0, so I'm not really super worried about that. I'm going to get the height, which is what is acting like the widths or the length in the problem. So we're going to put that in the function. I have to add 0 plus, and then I take this guy here, my height, and I multiply him by I. That basically counts up how many rectangles we have, okay? It helps us count those rectangles. So now what I need to do is I'm going to evaluate that for the function. So I know that this is 1 over n I cubed, or 1 over n cubed times I cubed. Okay, so I'm going to put that in my limit formula. So I take my width and I multiply by my length, or my height. And then I am going to add that up. So I'm going to add up all my rectangles, and here I go with the n again. It's supposed to be I. I equals 1 to n. And then in order to get as many rectangles as I possibly can, I take the limit as n approaches infinity. So I know that I can replace, well, first of all, I know all my n's. Those are not having an effect. They're acting like a constant because what I'm summing up is the i's. So I'm going to move that out in front. So the limit as n approaches infinity, 1 over n to the 4th. Okay, and then we've got the sum is I equals 1 to n of I cubed. Now, I know that that can be replaced with a formula. If I go back up to the beginning of the notes, right? Keep going. It's going to be replaced with this guy right here. So I'm going to put that formula in. And obviously you would have that formula on a test. You do not need to, or at least my test, you would not need to memorize it. So that is n squared times n plus 1 squared over 4. Now, if we kind of look at this, we know we've got an n to the 4th in the denominator with a 4. And then n squared there, once I FOIL that out, is going to be an n squared times that n squared. There's your n to the 4th. The only coefficient up in the numerator is 1. So I did some scratch work there. My actual limit would end up being 1 for the coefficient on the top, 4 for the coefficient on the bottom, so it would be 1/4. And then, and you know I borrowed these notes, if you can do these, what this means is that you are smarter than the average bear. And I don't know if you know who Yogi Bear is, but Yogi Bear was a cartoon when I was growing up. And that's what they used to say, that he was smarter than the average bear. All right, I'm going to stop it there, and then we'll do the next one.